The movement of the earth is regarded as the rotation and revolution of the earth as the earth tend to revolve round the sun. This movement tend to be double in form as the earth spin on its axis that is aligned to an angle of 23.4 degrees and also moves or revolve round the sun at the same time in an elliptical orbit through the ecliptic planes. But earth movement is regarded as the movement of the tectonic plates either by shifting, tilting, or any other form of movement in the crustal layers.
Hello my amiable students, in this lesson we'll be looking at the revolution of the earth, which is the second movement of the earth. The earth tends to move round or revolve round the sun in an elliptical orbit as is being tilted on its axis, moving on its rotational movement at the same time. On this elliptical path, the earth can be closer to the sun and it can also be far from the sun. This variation in nearness and farness is regarded as perihelion and aperihelion. But in its total phase or complete section of this revolution, it takes 365 1/4 days to complete a given earth revolution, which is regarded as one calendar year. And because we do not have 1/4 day in the calendar for every 4 years, it is now made a leap year to complete 366 days. The earth is closer to the sun on its path of the elliptic orbit in January or during January. This is regarded as perihelion, and when it is far like July or July 6th, this is regarded as aperihelion. So what are the importance and effects of earth revolution? 1. We have varying length of day and night. We are told that the earth is tilted on its elliptical path or on its rotational path to the ecliptic plane. So this makes the sun to be overhead in certain areas and to be far or oblique in other parts of the world like the Antarctic and the Arctic region. So on its path of revolution, the sun also tends to swing from one part to another, from the equator to the Tropic of Cancer in the northern hemisphere and back to the equator and back and down to the Tropic of Capricorn. So during this movement, the length of daylight tends to be shorter in places and in other places tend to be longer. First, let's look at the equator. When the sun is at the equator, all parts of the earth have equal day and night, which can be regarded as equinox. But as it swings to the northern hemisphere, parts in the southern hemisphere tend to have shorter daylight or shorter days, while the parts in the north where the sun resides tend to have longer hours of daylight in a complete day. So with this, some parts of the earth that are in the extreme part of the poles or that are resident in the polar region might never get light for 6 months, while the parts that are in the extreme part of the poles in the northern hemisphere will enjoy light for 6 months. So these areas that are devoid of light or that are having very low faint light are regarded as the land of midnight sun, when they tend to have sun as the sun swing to their hemisphere and they now enjoy the opposite, having 6 months of daylight.
The land of midnight sun is regarded as the extreme parts of the world where the sun is never overhead and the sun is on the other side of the hemisphere. So in these places, there are total 6 months of actual darkness and 6 months of actual daylight. In the northern hemisphere or in the Arctic Circle, the land of midnight sun are Falkland, Sweden, Oslo in Norway, as well as Port Elizabeth and others like Greenland and Iceland. When the sun rises in the horizon for a particular month, it tends to last for 6 months in a very faint and certain manner. Its rays tend to be oblique to the whole of the other hemisphere where the sun is present, making it to be tilted in the ecliptic angle. Then that side tend to receive 6 months of daylight, while on the other side where the sun is far, the side tend to receive 6 months of actual darkness.
But in its movement, the sun never tend to go beyond the area of the tropics to the poles. The apparent movement of the sun tend to end within the equator to the tropics. 2. We have altitude of the midday sun. When the sun is visible or apparent or closer to the equatorial region, all parts of the earth tend to enjoy equal day and night as regarded as equinox. But when there is imbalance in the daylight, whether shorter or longer depending on the area which the sun is resident in that particular hemisphere, we refer to that as solstice. So during equinox, the sun tends to be overhead at the equator and very closer and positioned to the center of the earth. Then as it swings forward to the Tropic of Cancer, areas in the northern hemisphere tend to have opaque light from the temperate region to the polar region. So the sun tends to be oblique and it tends to be directional from side or vertical in the equatorial regions. So the equatorial region is the only region that tends to enjoy vertical direction of sunlight, where the sun is always overhead or where the sun is always resident from January to December. So this varying height of midday sun tend to affect the temperature, range of temperature and monthly temperatures at the polar regions as well as the equator. So for the equator, the areas are always hot and conventional rainfall takes place from January to December, making the area to have excessive sunlight and excessive rainfall. While in the polar region, the level of sunlight that they enjoy is being dictated by the position of the sun or alignment of the sun during this ecliptic movement. So in the northern hemisphere, during June to January, tend to enjoy light in drastic reduction of increase to decrease level, while the place tend to be very cold during December, January and February due to lack of sunlight. While in the southern hemisphere, the opposite tend to take place during the solstice. The last effect of revolution of the earth is the seasons and changes in temperature due to seasons. In areas where the sun is never overhead, we have 4 seasons from the temperate region to the polar regions. So we have winter, autumn, spring and summer. In the northern hemisphere summer tend to take place during June, while when the sun is far from the northern hemisphere during December, January and February, the northern hemisphere tend to be very cold, having its winter. The reverse tend to take place in the southern hemisphere. So I hope you understood all the issues that have been raised in this module or in this lesson. I wish you the best look at the content page very critically and watch the video to be able to access or answer the quizzes and assignment attached to this lesson. Till our next lesson, I wish you the best.